class, here's our basic introduction to integration. We're going to do a quick flashback on derivatives. We did this so many times. If f of x was x squared, what was f prime of x?
2x.
2x. If f of x was 3x to the fifth, what was f prime, or what did we do to get f prime of x? Not just what was f of x.
You'd multiply 5 times 3.
Okay, so we're going to multiply 5 times 3. Where'd the 5 come from? Why did we do that?
From the exponent.
From the exponent. Okay, so we brought that down, multiplied it by the 3 that was just there. Okay, then what do we do?
You took the exponent and you subtracted 1.
Okay, so then we're going to subtract 1 from the exponent. 5 minus 1. So f prime of x then becomes 15. 15, is that right? 15x to the fourth. And then usually we would put our answers in a box because otherwise your professor gets mad at you. Okay, so that was what we did when we did derivatives. Now we're going to integrate, and integration is anti-differentiation. So we're going to look at a problem on anti-differentiation. First we're going to do two that we don't have to do anything for. We're going to integrate 2x dx. And integration is the inverse of differentiation. So if we're going to integrate 2x, what do you think we're going to get?
So you would get x squared.
Yeah, you get x squared because that's what you got. That's just the backwards. So no real thinking yet. And I'm going to give another one that doesn't require any thinking, and then we're going to talk about it. Now we're going to integrate 15x to the fourth. And I'm going to kind of talk a little bit about the symbols for just a second. This dude right here, he means integrate. And then you're going to integrate this stuff, and this means with respect to x. So this is the stuff you're dealing with, and this tells you what you're doing to it, and this tells you what variable you're dealing with. So, well, we just differentiated something and got the answer of 15x to the fourth. So what do you think the integral of 15x to the fourth is?
3x to the fifth.
3x to the fifth, because we have that problem above. Okay, and then we actually have to do this thing called plus c. It's not really called plus c. We have to add a constant, because up here, if we had had x squared plus 7, the derivative still would have been 2x. And up here, if we had 3x to the fifth minus 286, the derivative would still be 15x to the fourth, because the constants go away because of what the derivative is, which we talk about in class, not right here. Okay, so let's talk about the nuts and bolts of integration now. Okay. And we'll do it with this 15x to the fourth. 15x 4 dx. So we're integrating 15x to the fourth with respect to the variable x. All right, so when we differentiated, we brought down this exponent, lowered it by 1, and multiplied it by there. So there was this multiplication thing going on that we always did first. In integration, since it's the opposite, instead of multiplication, what are we going to do?
Division.
We're going to divide. Okay, so we're going to have 15x to the fourth, and we're going to divide by something. Now, with derivatives, we lowered this power by 1. So what do you think we're going to do now?
Add by 1.
Add 1. Okay, so we're going to go ahead and add 1 there. And then here, we're going to divide by the raised exponent, so that it all kind of cancels out and makes everything pretty. So this gives us 15x to the fifth divided by 5, which we can simplify to 3x to the fifth. And then we've got to add our plus c. Okay, which is what we got just looking at what we had done above. So let's do a couple examples with these steps and then talk about things that we need to know. Okay, couple examples. Let's do one more really basic one. Let's integrate 5x. I'm liking 5s today, I don't know why. 5x to the, let's do fourth, that'll be fun, dx. It was a 4 last time, wasn't it? I probably should change it. Oh well, whatever. Okay, so 5x to the fourth dx. So we're integrating 5x to the fourth with respect to the variable x. So this is the thing that we're playing with right now, is 5x to the fourth, and we're anti-differentiating or integrating it. So we know we're going to keep it kind of the way it is. Okay, and what are we going to do with the exponent?
Add 1.
Add 1. And what are we going to divide by?
4 plus 1.
4 plus 1, which some of you are all fancy and can do that all in one step, but you know me, I'm not very fancy. Okay. And then the 5's cancel out. We get x to the 5th plus c. So this is our answer. If that's what we end up getting, how can we check an integration problem?
Take the derivative.
Take the derivative. All right, since they were inverses, let's make sure that works. So if we've got x to the 5th plus c, and this is our integration thing, then, or that's what we got to the answer to the integration problem. Most textbooks call this big F of x, okay? So to check it, let's check. Okay, we're going to check that after I turn my cell phone off because it's making all these horrible noises. Okay, off. Let's check. If we were in class, I'd have to bring cookies or something, right, for the cell phone going off. We're going to check with differentiation. So we're going to derive it. We all know how to derive by this point in the game, and the c goes away. So we look at that and we say, oh, isn't that what we started with? There, and we say check, we're good. But be careful, make sure that you know that this is actually what you get when you integrate. Are we ready to get a little harder?
Yes.
Okay, let's do a little harder. Let's integrate. Oh, here's one of our happy friends here, square root of x dx. What are we going to have to do first?
Rewrite.
We're going to have to rewrite this because this is not coefficient variable exponent, and everything needs to be in the form coefficient variable exponent for us to do anything with it. Okay, let's rewrite this. So we're going to do integral. How do we rewrite square root of x?
The root over the power.
Yeah,
over root.
right, power over root. And what goes here?
1 over 2.
1 over 2. Okay. Okay, and already this looks friendlier. It's got a fraction in it, but whatever, we can handle fractions. Okay, so we're going to integrate it. And as soon as we do that, this stuff goes away because we've done what it asked us to do. So we get x to the 1/2. Okay, and what do we do the exponent when we integrate? Do we add or subtract? Add, okay. Which is very backwards from what we've been doing all semester. Do we want to write a 1? We're adding it to 1/2. What should we write?
2 over 2.
2 over 2. 2 over 2. Okay. And then this thing has to also go in the bottom. Ugh, doesn't this look gross? You think it looks gross? I think it looks gross. Okay, but that's okay. We can handle it. So we get x to the 3/2 over 3/2. But that's definitely not okay. Like, we can't leave it like that, right?
Yeah.
What should we do?
You can simplify it and bring the fraction up.
Bring the fraction up. Okay. Well, there's a couple different ways we can deal with that. I like to show kind of how it works, and we may as well. We're here, right? Okay, so x to the 3/2 over 3/2 really means x to the 3/2 divided by 3/2, which we know means x to the 3/2 times 2/3, because you flip. So that means we get 2/3 x to the 3/2, and then we have to add a little plus c, which we'll talk about because that constant, if it had been in the original problem, would just go away when we derive it. So it has to come back when we integrate. Okay, another way to look at this, how do you deal with the 3/2 thing on the bottom? I digress, don't I? Is to multiply this whole thing by 2/3 over 2/3. Oops, that's not thirds, is it? Okay. And these guys cancel each other out, and then this can come up front. So if you don't want to look at it as a division problem, you can just look at it as a simplifying a fraction problem, kind of like that. So let's do one more really quickly, and then I'll give you all a couple to try. Let's integrate 1 over x to the 4th minus 3 radical. I don't know how ugly this is going to be. We'll have to see. Let's make that a 5. And let's go ahead and actually also do plus 7 dx. That's a lot of stuff, but we can handle it. Okay, what do we got to do first?
Rewrite.
Rewrite. Okay, we're going to rewrite. So we still haven't integrated yet, so we still need this thing. So how do we write 1 over x to the 4th?
X to the negative 4th.
X to the negative 4th. Okay. Then there's this power over root-y thing again. So we still keep our 3 there. We get x to the, what's the power?
5.
And what's the root?
2.
2. Some people, all the way through, put a little 2 there just to make themselves happy, and if it makes you happy, I think you should do that. Okay, and then there's that same thing we did with derivatives, where some of you are going to want to write this as a coefficient variable exponent, where you write 7 x to the what makes that really do nothing?
0.
X to the 0. Okay, so because x to the 0 is just 1, but it kind of helps you have the coefficient variable exponent. And we have not taken the integral yet, so we've got to write dx. All right, let's keep going. So here, what I like to do is just write all the stuff again and then think about what I'm doing with it in a moment. I write it all again. Okay, and then I do what I'm going to do to it. I guess I can still use a black pen. Okay, so we're integrating, so do we plus or minus?
Plus.
Plus. So we're going to do plus 1 and then divide by that. And here we're going to do plus 2 halves and then divide by that. And then here we're going to do, well, it was a 0. We're going to add a 1 and then divide by 0 plus 1. Very exciting, very gross. We can't leave it like this. So here we've got x to the negative 4 plus 1. What's negative 4 plus 1?
Negative 3.
Negative 3. We all make mistakes on that one. Maybe not all of us, but those of us who are human and imperfect, we do. So the negative 3 goes down here, which is a little ugly. We might rewrite that. And then we've got, let's not make this pretty yet. Okay. 5 halves plus 2 halves.
7 halves.
7 halves over, we'll have our 7 halves here. And then we've got our plus, this is really dorky looking, 7x to the 1st over 1. Okay, this is still a little bit too dorky. I can't handle it. Should we go coefficient variable exponent?
Yes.
Just to be what we're used to. To be what we're used to. That's proper English, isn't it? Okay, so negative 1/3 x to the negative 3 minus, we've got 3 and we've got a 7 halves. Let me go ahead and do a little bit of math up here. I'm going to do it over here. It's kind of non-traditional, but so am I. So we've got 2 sevenths, 2 sevenths. The 2 sevenths and 7 halves cancel out, getting rid of that denominator. And then we get 6 sevenths here from the 2 times 3 divided by 7. Okay, x to the 7 halves plus 7x to the 1st divided by 1. Do we need either of these ones? No, or the denominator. We're just done. Okay. A lot of you are not going to be able to do that. Those of you that truly, really understand what's going on, which of course we'll talk about later, because when you differentiate 7x, that line of slope 7, the slope is 7, so the derivative is 7 everywhere. So when you integrate it, and we'll talk about the meaning again in another video or in class or something, you're going to get the 7x. And we always need the plus c so that whatever constant we had when we differentiated comes back. Okay, so this is the answer to this one, and I'm going to give you a couple to practice. And if you bring your practice problems to class next time I see you, that would be a really good idea. All right, here's 3 examples or practice problems for you all to write up and bring to next class. Feel free to discuss them on the discussion board, but you're going to need to turn them in at the beginning of next class. Take care. Thanks. Bye.